Our speaker is Ed Nabroyzky. He is the Chief Solutions Officer for Omni-ID, and he's going to talk about some of the best practices for deploying RFID in harsh environments. So, Ed, just give me a second to give you control. Okay, Ed, can you hear me?
I can hear you. Can you hear me?
I can. You're good. So you can
excellent.
Take control.
All right. Thank you. I think I've got control of the presentation here now. So thank you, everyone, for joining today. And, Mark, what a great introduction. You laid a great foundation for RFID and all the key features that you have to be concerned about on a project, everywhere from infrastructure to gaining consensus and mitigating risk with pilots. I would highly commend the wise words you heard from Mr. Roberti, who's been in the industry a very long time. I'll try and build on that and talk a little bit about this theme of IoT and RFID and why we need it. And again, some specific use cases in harsh environments, which is a very key piece and what we're here to talk about today. A key piece of what we do at Omni-ID, designing tags for harsh environments and collaborating on many projects all over the world in very difficult environments, difficult circumstances. So let me start by talking a little bit about why. Why do we care about RFID, and what are you probably thinking about as you're here on this call? Assets are moving through our enterprises every day, being transformed into different products, different services for our customers, being rented, being leased. And the concept of managing assets, understanding their flow, understanding their state, the changes that they go through, is a huge piece of creating the digital enterprise today. There's no question there's a huge appetite for having transparency in our processes and gathering the data to improve the processes, enhance compliance, security, authenticate, many other reasons why we're all turning to that. Big data analytics is driving a huge change in some of our very largest corporations around the world. So industrial IoT, with RFID at the heart of it, is really about making that material smart and visible to all those different programs that want to use it in transforming the enterprise. That concept of digital transformation, if it hasn't hit your business yet, it soon will, but I suspect if you're on this call, it's because digital transformation is already a theme at your company. You're trying to understand how to do that and how to get the data that you need. What is digital transformation really? If I can make my slide flip. It's really about creating data at the edge. We all have, even traditional companies have back-end data systems that have digitized information that we're passing to our MES systems or our ERP systems. But at the edge, we're still mostly reliant on paper, on printed tickets, on different barcode scans or data entry activities by our workers. The digital enterprise really creates that data and does those transactions all the way out to the edge, creating a digital thread that runs through our entire organization and has the ability of really looking at the process from stem to stern completely through that electronic means. Industrial IoT is about enabling that, making the machines smart, the material smart, and digitizing the activity of the people so that we can see the enterprise as a whole as a digitally transformed digital enterprise. That's really the thirst that's in the market today, trying to get there. We do this for asset management, to be able to get better control of our inventories, our machinery, our equipment. We do it for process optimization, to make sure that our workflows are effective and to improve the reporting of those workflows, and certainly for risk management, to be in better control of everything happening all the way to the edge of our enterprise. So a few key applications that we deal with all the time at the edge, and a theme for this webinar, security, employee safety, lots of project tracking and progress applications, and lots of supply chain processes. All four of these apply in the harsh environment specifically, and maybe the employee safety one is even more important in harsh environment conditions, because quite often where our assets are in harsh environments, our employees are as well, and employee safety takes a larger role. Some of the applications I'll share with you today will focus a little bit on that side and how RFID can help there as well. But these four would be dominant themes within the harsh environment use cases we have for RFID. So what do we mean by harsh environment when we talk about RFID? One example might be what we're showing here on this slide. This is the kind of testing we do at the Omni-ID labs on many of our harsh environment tags. It can vary from full immersion applications. We design applications that have to be tagged under snow, under ice, very difficult conditions where the tag has to be sealed, but also perform under that kind of loading of those liquids. that's a very harsh environment. Torque is a big one. We have a number of places where the tag has to be attached to a moving surface. One that comes to mind are garbage bins that we do. Outside garbage bins are collected and moved, and the amount of torque that can happen on the face of even a steel skiff or on a plastic garbage utility bin can be tremendous. And so taking into consideration torque and movement of material is important. Shock and vibration is a huge factor. The shock and vibe tables that we use to replicate bouncing around on a truck or moving around within a factory and being slammed down on concrete are really crucial in the design of that transponder to make sure it can survive and the attachment points can survive. I think Mark was quite right in mentioning that one of the big failure points are the solder joints that happen between the chip and the antenna assembly. If it's not designed correctly and tested correctly for that kind of vibration, quite often that's where you'll have breakages and failures, preventing the tag from reading. We have a lot of applications with compression being a key factor. I think Mark mentioned pipes banging together in the oil fields. That's a huge one for us. And making sure that tags can be designed to withstand all sorts of pounding forces, impact forces, and compressive forces is often a design criteria. And temperature, which is one of the most common harsh environments we have to deal with, whether it's northern ice or desert heat, or sometimes all of the above, as tags will cycle through both the ice and the heat through their lifetime. Being able to withstand those temperatures and also the thermal shock of moving between those temperature ranges is a huge challenge for those that are designing these tags and transponders to mount on your goods. The good news is, as we expose these things, you may have come to this call with fears that my application is so severe, no tag could ever survive it. You know, I'm going through a temperature or with a chemical or with a physical pounding that a tag can't survive. In general, that's probably wrong. Today, there's been such great advances in building UHF RFID transponders in particular, but also other kinds of transponders, that there's probably a tag that can survive even the harshest environment that you can throw at it. And if there isn't, I know a great engineering team that loves the challenge of designing something new that will withstand new conditions. So you should probably dispel that myth from your mind that my process is not taggable. Chances are it is, and there's some way that we can accomplish the mission if you want to digitize that to the edge. So to build on what Mark said about what it takes to make an asset management solution to implement RFID, you really have three key things you need to worry about. We focused a little bit on the tag to start with and building that to be appropriate for the environment. As I mentioned before, there's more options than there's ever been to make sure that you can find something that will survive. You also have to worry about your readers and your reader infrastructure. The tag is only one part of the equation. There has to be a way to pick up that reading of the tag. You're generally talking about distances of tens of feet, sometimes hundreds of feet, depending on the design and what you're trying to do in the most extreme cases. But usually you're trying to get, you know, in that kind of a range, 20, 30 feet. That can mean you're using handhelds, as you see here up at the top left. It can mean fixed infrastructure, traditional portals, whether you're driving through with a truck or driving through with a forklift. Increasingly, we're seeing drones and automated vehicles with readers mounted on them so that they can drive by and do inventory sweeps or pick up the appropriate material. That's a really important growth area in our marketplace today. And we see some more exotic things, like the picture you see the Marine Corps sergeant up in the top left, where he's got a solar-powered reader that he can drop down on a beach and read equipment coming off the boats in any battlefield in the world. There's really a lot of variation in infrastructure and a lot of good options there. So much as we've talked about, tags have changed a lot and matured a lot over the last few years. Certainly readers have too. And whether it's options to connect by Bluetooth to your smartphone, or whether it's mobile solar options like we're showing on the side, or drones or robots, chances are that already exists. And if you need it, there's companies that can supply it, and you can get pointed to the right person. Similarly, software. So much software is required here to read and manage these assets. There's a lot of choices and variations. There's certainly a lot of companies that specialize in particular areas. Almost all of it has been baked into speak to back-end systems, ERP and MES systems, and I think you'll find a lot of options there as well. So quite often we find from our customer base, you start from one of those two ends, either from the tag or from the software. Your primary concern might be, you know, can I actually tag the thing I need to tag? Nothing will survive it. Or your primary concern, especially if you're an IT department, will be, how do I interface to all this stuff, and will it be seamless with my existing system? The poor infrastructure usually gets wedged in the middle and is thought of last after both of those two are solved. But In general, you need to think about all three, and a good holistic approach is to go through all three in your project plan at the same time and make sure you can design the right system appropriately. So let's talk about a couple of applications and again, give you some insight into what's possible today. Security is a big application in the harsh environments as well as all other environments as well. Often the concern here is to ensure that material that's delivered to your site is genuine and authorized. We're seeing a huge increase in counterfeit materials. There's certainly been some new government regulation that's guiding the industry here in critical installations, infrastructure, to ensure that authentic materials are being delivered to site and being installed in major bridges, infrastructure projects, reactors, things like that. RFID can play a key role here. Transponders can be embedded in a way that are impossible to be tampered with. Even labels or stickers can be put down with tamper-evident or tamper-resistant capability. Tethered tags or lockable tags that break when you try and detach them are another method we've worked with different companies on. So these different types of technologies work very well with RFID, ensuring that your supply chain is authorized and genuine. Certainly with blockchain technology and where that's going, and being able to use that open public ledger to write some unique values into the tags to also ensure from a software perspective the material is authentic, can be a real powerful way to ensure security of your project and your site, if that's a concern for you. Employee safety, we mentioned at the outset. In harsh environments, it also means that sometimes our employees are in harmful situations or potentially harmful situations. There are many tags that are made specifically, for instance, to go on the hard hat of a worker. Badges and fobs are very common, like the key fob or the employee badge solution that you see in the slide. Tagging your employees means that you can read them just like you can read all the other assets flowing through your project, knowing where you've seen them, knowing where they are. If you're using an active technology versus passive, you get the ability to add some additional sensors like motion sensors and the ability to broadcast emergency situations by pressing a button, such as the tags that you see on the bottom here that have buttons on them. The employee can say, I've fallen down, I need help. That can really help enhance your employee safety. So whether it's a passive badge to give just access control or last seen, you've entered the yard, you've left the yard, or whether it's an active solution that gives you traceability and breadcrumbing of where the employee has been and dwell times and emergency calls, RFID can play a key role here in employee safety. Project tracking in the harsh environment is often a big theme because many of our harsh environment applications are large-scale, large capital projects with materials spread out over very vast distances. The idea that the material can be smart, and what we mean by smart material is the material has a unique identifier and it can beacon or it can communicate with infrastructure to tell the system where it is and sometimes even where it should be next. That smart material is a key part of your project tracking. RFID has gotten so cheap now that you can apply certain tags to different materials and leave them on through the entire process. We have customers that in a building project, for instance, can scan through the walls and record which components have been installed and verify, especially critical components, even where they're out of sight, that they are installed directly on the project. We have customers that are doing pay-on production systems where every day they are sweeping with RFID to verify how much material has been installed and paying the vendor based on that progress. So it gives a lot of options in project tracking using RFID to very quickly track progress and understand what state your project's in. Certainly for your vehicles and your tools, it's been a theme for a long time to be able to tag those vehicles so you get access in and out of key parts of the project, and tools so we can understand how much time. There's companies that build a whole business model on renting tools and time on tools, and they do that through RFID to enable them to know which tools have been checked out and checked in and what the time of use is without the burden of doing that with manual operations or paperwork. And of course, personnel logging in and out is an application most of us are familiar with, as we all use access badges almost as a matter of course now in our daily jobs and lives. Supply chain is a huge application, delivery and logistics to ship and receive goods in and out of large capital sites, again, harsh environments, being able to keep tags even on these very difficult products. I wanted to show you examples here on the right of some of the types of things. Large iron pipes in a pipe yard, they can still be very effectively tagged either through the end caps or through sling tags around the pipe, or even labels stuck on the pipe, depending on your application and what you're looking for. Shackles and large pieces of equipment which are typically difficult to handle, being able to verify them and their delivery and their state. Supply chain applications here are really important in the harsh environment, and just because it doesn't look like a stockroom at Walmart doesn't mean you can't use some of the same principles to be effective in managing your deliveries and your inventories as they come onto site. So we'll go through a couple of customer success stories here, just again to give you a vision of where you can use this technology even in harsh environments. We'll talk a little bit about some of these here, laydown yards, securing your facility, some chemical storage, transport that we're doing, and construction mats and rolling stock inventories, just because they're things that maybe you didn't think of before. Laydown yard inventory, as we mentioned, one of our classic harsh environment applications is laying material down in a large outdoor yard. In many cases, when you have large cap construction, you have to stage that construction, and deliveries happen continuously of different key assembly pieces or materials. Those yards can get very large. We have some customers that have 25 square miles of yard where they're laying down all sorts of pipes and steel and different components. We have large docks where ships are being assembled. So these can be very significant. They have all the challenges of outdoor weather and difficult environments to deal with. So the fixed infrastructure can be expensive. Often people approach us and say, I'd love to be able to do the inventory in my yard, but my yard's so large, it would be cost prohibitive to put infrastructure out there. The good news is there's been huge advances in using mobility devices, whether it's handhelds or more commonly now drones or other vehicles. We certainly have people that wire up a pickup truck or a lift truck that goes into the yard regularly to pick up material. And by putting antennas on that truck, you can do inventory sweeps and maintain your infrastructure state just automatically every time you drive in and out. That's a really effective and cost-effective way to maintain inventory in a large yard. The drones, I've referenced a couple of different companies we work with. I think there's a story on our website on New Age Steel, keeping track of different steel components out in the desert. Really interesting little application. Pink, one of our partners doing yard solutions with their drone, there's some great videos on YouTube showing how that works. And I've included a link here. Jovix, one of our partners, using a drone to also scan and sweep inventory in capital construction. So these pre-programmed sweeps of drones are, again, going to be increasingly popular options, and I expect you'll see more and more of those in the coming years. They're very cost-effective and very inexpensive to be able to put together a good system and solution. Another big area for us in harsh environment is delivery verification. Good example here is a secure facility we do in New York, where we need to verify that these trucks that are coming are authorized to be on site, that they have a load that's authorized, and to track the movement of that truck in the facility. So think of RFID in this sense, that you can check somebody in, gather all their attributes electronically, associate a tag ID with that delivery, and then attach it to the truck. One of our very largest projects now in India is managing all these truck containers coming in and out of the ports across India and tracking them across their different roadways in their Smart Cities project. There we use a magnetic latch to attach the tag and attach to the outside of the truck. As the truck goes through its various stages, it's now tagged uniquely and can communicate with the infrastructure. Very simple to do, but very, very effective in securing that facility and verifying the deliveries with an electronic record of what's delivered when and by whom. You can also verify and map routes to make sure that they're proceeding on the right route. As we all know, terrorism continues to be a greater and greater concern in our society, and someone driving on your facility with a truck can be a potential challenge. So you want to make sure that if they're authorized to go to Dock 4, that they drive to Dock 4, that they stop at Dock 4 and nowhere else, and that they didn't dwell somewhere else. And so RFID can be used to verify their route and their delivery pattern. We talked about security and some of the options. This application actually uses a magnetic latch. It's an RFID tag that when it attaches magnetically, it latches and flips a bit so that you can know that it's been attached. And if anyone tries to remove the tag without authorization or sending the appropriate code, the tag then alerts that has been removed without authorization. Again, another security feature that can easily be built into your project. An environment that you may have thought it's impossible to have a tag in is an explosive environment. I think Mark mentioned that in his opening piece, that even explosive gas environments now are very suitable for RFID. Obviously, passive RFID is perfect for that with no power source inside, but even a passive RFID tag needs to be constructed or at least coded with dissipative materials that will not allow static buildup on it, and needs to be certified under the ATEX standards. So certain passive tags can be sourced that are qualified for ATEX and certified. Even active tags, active RFID that have batteries in them, are built now with ATEX certifications and can withstand explosive environments, Class 1, Div 1. So if you thought that wasn't possible, I want to point out again a success here of a large energy company that used these active tags certified in a gas plant, and were able to get all the correct infrastructure installed and certifications to still take advantage of that technology, even in that environment. Another example is vehicles. We do a lot of applications with vehicles. Probably the classic example that I'm showing here is the Marine Corps. All the rolling stock, tanks, Humvees, Jeeps, coming back from theater need to be marshaled in large yards and counted and inventoried. It's a huge logistics issue, but the Marine Corps being able to deploy tags on every one of those pieces of rolling stock and read them coming on and off of different carriers, whether it's air or sea, and being able to marshal them in yards and understand which ones need to be maintained, which ones have been back from theater the given time for rotation, is a really important part of their system. So if they can do it with the amount of material they have, of course your organization can as well. It's a very effective way to keep track of that rolling stock. The standard operating procedure that they had prior is a really good case study. I've included the link here on this slide that lets you go to YouTube and watch the comparison of their previous SOP versus the new one with RFID. You'll see the testimonial there of some of the Marine Corps staff of how much time and money it saved them, being able to automatically count this rolling stock coming in and out and keep track of it. So it's a great way to think about an application for yourself if you're thinking about mobile assets and taking care of the logistics there. Another great example that I can share is harsh environment construction mats. Think about these difficult mats that have to be put down in swampy ground, muddy ground, and how do you count them to make sure you've got the right mats down, make sure you pick them all up again at the conclusion of the project. Certainly there's increasing regulations on environmental impact, making sure that you don't have foreign bodies attached to the mats, going through a cleaning process before they're deployed to a new site, that they're not carrying invasive species with them. That challenge is a difficult one to do manually, but it's difficult, or many people think very difficult, to create a tag that can survive that kind of physical pounding as well as the mud and the water that are inherent in the application. So this was a great success story in that the tag was actually able to withstand the difficult conditions and perform well enough to be able to work in the application really, really well. So if you, again, thought it wouldn't be possible, it certainly is. The reader system can easily be attached to the vehicles, much like you see here with a large excavator being able to put mats up and down, being able to put antennas on the boom and be able to read the mats as they're being picked up. Again, is an advantage of UHF RFID. Distances can be tens of feet and still be effective and reliable. That really enables this application versus close contact reads of other technologies. With that, I wanted to conclude my section. I hope these examples and different success stories have opened your eyes to different uses in harsh environments for RFID, and I'm happy to take any questions that you have.
Okay, Ed, thanks very much. We do have a couple of questions. I want to go back to that one that we had earlier about corrosive, chemical corrosion. Any suggestions for protecting antennas that are exposed to corrosive chemicals?
Yeah, you have really two options here. You either have to pick an antenna that is inherently resistant to that particular chemical. We have PhD material scientists that spend all their time just matching materials with the environment. So it's sometimes possible to pick an antenna that will inherently resist the corrosion. More commonly, though, you're going to have to coat it with something that will resist the corrosion. Whether it's a completely embedded application where you're going to immerse it in something that's going to protect it, or whether you're going to encapsulate it, you're probably going to have to do some kind of covering or coating to do it. But you'll start first with, can you design something inherent? And second is, can I cover it?
Okay. What tags can you recommend for metal pipes in very harsh weather?
Yeah, and that's another great question. The metal pipes mean that you need to have a structure that will resonate on the metal. So that's step one. Once you've got that type of tag, what we call a plasmodic structure that can resonate on the metal, Now you have to think about the weather itself. Today, labeling has become so good that you can produce a nice laminated label, maybe with an over-laminate, that it will even survive very wet conditions. You don't necessarily have to go to a really hard coated tag, although traditionally that's been the option, is to have an encased or a molded tag that will certainly be impervious to the weather. So you have that option, or you go to a label. But the more common problem you have on the metal pipe is the clanging together as the pipes collide. If you don't have that problem, if your pipes are delivered one by one or are always isolated in the way that they're delivered in cribs or crates, then all you have to worry about is the weather. Probably your most cost-effective is an outside or outdoor label that's been laminated specifically to withstand the environment.
Okay. In the current generation of tag technology, what's the temperature limit that a tag can withstand?
This is one of my favorite questions because we get asked it all the time. A very typical temperature requirement is getting up to around 450 degrees Fahrenheit or 225 Celsius. There's a lot of options at that temperature to withstand that kind of environment. We do also see more extreme temperatures than that, getting up to 600 degrees. Certainly there are options for that. I think it's very uncommon. Once you get beyond 600 degrees Fahrenheit, there are some tags that can survive that, but they're very, very specialized and very rare.
Okay. Developing an RFID system. We're developing an RFID system that will be deployed in 29 facilities globally. It involves plating and wet chemistry, high temperature applications. How best to protect the antennas, tags, and readers in such an environment so that they continue to function?
Yeah, you really do need to have expertise on this project. So the first thing I would have you do is take a system or a vendor that's used to doing harsh environment RFID systems. They will have engineers, as we do, that are used to analyzing the requirement and making sure that they've got either something that inherently survives or can be encased in a way that it can survive. Once you've got that as a concept, really going back to what Mark said in his lead-up comments, you need to do a pilot and run it through that process to expose it to all the different conditions. What works on paper, sometimes you'll find flaws in your process. So start with a design with a qualified vendor, have that design prototyped, have that prototype run through your pilot through a series of use cases over a short period of time, or perhaps even an extended end-of-life test, and then you'll know that you've got a good solution, you can deploy it. But it certainly is possible. You just need a close partnership with an expert company that can do this for you.
Okay. Where can we find more information about the Omni-ID submersible tag?
There's certainly information on our website shown on the slide right now at omniid.com. But if you'd like to have some additional detailed test information or results or some application stories, just email me directly and I'd be happy to supply some additional background information.
Okay. And last question, can you tell us about battery life management in active tags?
Yeah, battery life management is really key, and many active tags are configurable in that you can set the beacon rates or set the behavior of the tag so that you can manage your battery life. I know for us, we have an active tag that has to live in the winter time, and we even monitor the temperature swings so we can understand when it's noon and when it's midnight, and not beacon during the night when no one's taking inventory, for instance. So if the tag is very, very smart, it can have embedded in it some logic that helps extend battery life. If it's not smart and you're doing that through software controls, there's often configurable settings that help you manage it. Most tags on the active side now are being designed for multiple years of battery use, anywhere from 3 to 5 years. And so I think you'll find that that's going to be typical as you look at different active tag technologies. You will have some replaceables and some non-replaceable battery technologies. I think you need to consider that when you think about it. When you're getting out to 5 or 6 years of battery life, it really doesn't matter very much having a replaceable battery, because usually the tag is destroyed or there's much better technology 5 to 6 years from now that you'll want to replace it anyway. So think about whether replaceable is important for you or not. Usually replaceable means that you'll have less battery life inherently, but it gives the advantage of swapping it out. So battery management technology is first choose the right type of battery, replaceable or fixed. Get the settings on your tag correct for your application, so you're saving power as much as possible during times you don't need it to be beaconing. And the third strategy I'd mention one we employ is make your tag a hybrid tag. We have passive and active in the same tag so that if the battery does die, you can still recognize the tag through a passive RFID read, even if there's no battery in it or the battery's dead. So you never lose your asset tracking capability or the information associated with the asset.
Right. Okay. Ed, thank you so much. Great presentation. We appreciate your support for this event.
Thanks, Mark.